Welcome to Agrifood Conversations, brought to you by iSelect, the Van Trump Report, the Yield Lab Institute, and Family Farms Group. I'm Hannah Hund, an analyst on the iSelect Fund Ventures team, and I'm excited to welcome you all to our discussion today. Agrifood Conversations is all about driving innovation in agriculture. Each month, we highlight a specific theme, including emerging topics such as soil health, plant genetics, vertical farming, and aquaculture, to name a few. This month's theme is supply chains, and on today's call, we're joined by Nico Kuruma, International Sales Manager for Netled. With over 30 years of experience with indoor growing technologies, Netled is developing the world's most advanced vertical farming systems and innovative greenhouse lighting solutions. Long experience in horticultural lighting design in challenging northern growing environments has helped the company create smart solutions that work for today's vertical farmers. Netled has two business areas, Vertical Farm Vera and Greenhouse Solutions. Each of you knows companies are more likely to succeed with the right network of customers, talent, investors, and advisors. We've invited you to this call because you are some of the smartest, most talented people in Netled's market. You are potential customers for Netled's products and services. You have built a company similar to Netled's, or you are a sophisticated business person or agricultural professional who understands the market and the challenges and opportunities Netled may face. Before we get started, we have a quick poll question to get a better idea of who we have on the call today. Please take a few seconds to answer. A few process comments while that poll's running. We are not soliciting investment. This presentation is to provide information to help Netled find customers, mentors, and other strategic partnerships that can help them grow their business. You are all on mute. You can use the chat window to ask a question at any time. This presentation is being recorded and will be available for replay. So without further delay, I'm pleased to introduce Nico Kuruma, International Sales Manager for Netled.
Okay, thank you, Hannah, for the introduction. And thanks for the organizers to having this chance to speak about our company and vertical farming and how this whole concept can affect the food supply chains. And of course, I thank everybody for joining this webinar. And yeah, I say good afternoon. I suppose most of you are from North America, and greetings from Finland. It's 11 p.m. here and sun has just set, so I'm using artificial lighting here. But let's not think too much about the time difference and start this presentation. Like Hannah mentioned at the start, Netlet originates from tomato greenhouse business, which was established in 1987. So the company has over 30-year experience of indoor growing technologies. And we reckon that is quite a unique background for a tech company in this industry. Netlet was founded in 2007 to design LED fixtures. So we can be considered as a pioneers of the industry. Vera, which you see the trademark on the left-hand side, it's our brand that covers turnkey vertical farming solutions of Netlet. But today's subject is that how vertical farming can disrupt food supply chains. That's a really interesting question. I think at this COVID-19 crisis, this whole corona situation has brought this matter to surface in a different way how it was a few months ago. Although vertical farming has been in public for quite some time already, but now it has came into surface in a different way, I reckon. So let's dig deeper into logistics at first a little bit. Logistics and supply chains affect our everyday life, whether we notice it or not. And like every other field, logistics has strengths stemming from technology developments and changes in customer behavior. And at first, I I make somewhat brave comparison with vertical farming and 3D printing. In logistics, 3D printing will affect supply chains quite significantly in the future. And so 3D printing can bring the production closer to consumers, close to distribution centers, other production facilities, and so on. And if you think about vertical farming, it has same sort of capabilities to bring the production closer to consumers, closer to distribution centers, closer to the grocery stores, and so on. And other claim to make about logistics, what comes to so-called fresh supply chains, online food shopping is booming. And this global corona situation is accelerating this particular trend, at least here in Finland. A lot of people are now shopping groceries online rather than going into the grocery stores. And that is something that might even actually stay as a permanent situation after this crisis. And this online shopping, I would claim that this brings stress to the current food supply chains. And then if we think about the situation at the moment, and let's focus on the US, since I understand that most of you are living in North America. So how they are at the moment. On average, food travels about 1,250 miles, which means that transportation and storage consumes a lot of fossil fuels. And one could make a claim that it can't be affecting the quality of fresh products. If we think about lettuce, for example, it has extremely high water content. So basically, we are transporting water when we are transporting lettuce all the way from California to, for example, to New York, all those 2,800 miles. The research says that it can take up to 5 days for food to reach consumers, and it's not too rare to find 2-week-old so-called fresh products in grocery stores. That is according to research. I'm not sure that whether it's true or not. Maybe you know this better. Also, food sovereignty is an issue that COVID-19 crisis has brought on the surface. Now we understand that closed borders make transportations harder, and also for food to travel across the countries and across the continents. And of course, vertical farming is one solution addressing this matter as well. And the demand for fresh and local products can be considered as somewhat global trend. So-called CGG food, clean, green, and gourmet, is a trend not only in the Western world, but also in Asia, for example, in China, where the middle class and upper middle class is rising. In 2016, a survey made by National Restaurant Association, where they interviewed chefs across the US, showed that consumers have the desire to buy fresh and local products. Local food sales in the US grew from 5 billion to 12 billion between 2008 and 2014. In 2017, it was predicted that sales would jump up to 20 billion in 2019. If someone has updated info on this, please share it for the rest of us after this presentation. Vertical farming enables production of high quality, fresh and local products, but also constant all year production that can also work in counter cycle of normal production seasons. And of course, economical feasibility needs to be studied case by case when we think about vertical farming in general. But when we think about and speak about local, how can we define that? each country and nation has different views on this. Here in Finland, production needs to be within the city or very close by to be considered as local. Maybe in the US, production in the same state can be local, meaning that you don't need to go to Manhattan to be local in New York City. I'm sure the listeners of this presentation have much better understanding of this as well. Actually, just today, I spoke with a gentleman living in Ontario, Canada, and we spoke about this locality. And he said that when he's living in Ottawa and products coming from Niagara region, which is about 5 to 6 hour drive, is still considered to be local in Ottawa. So it's produced in the same state, so that's local. And at this point, I wanna say that vertical farming is not synonym for urban farming. So vertical farming, to make an impact for the food supply chains, it doesn't mean that you need to go, for example, to the center of Manhattan or the center of any cities. You can be outskirts of the big cities, close to distribution centers and so on, to make and disrupt food supply chains. There can be different solutions how vertical farming can disrupt the food supply chains, and here's just some of those that I think that will be viable or already are viable. A large-scale vertical farm close to a distribution center can make a big impact to the market by producing big quantities. A distribution center can be, for example, for a wholesaler or a retail chain, and a vertical farm could even work in the same building. A large-scale vertical farm close to the city can produce veggies for different grocery stores and offer truly fresh and local product in also big quantities. And small-scale urban vertical farm can produce ultra-local products and with possible higher margins. And as an extra solution at this point, a growing cabinet in the grocery store, so inside the store, can work as an independent growing solution or as a showcase along bigger operation, meaning that it works more like a marketing tool rather than growing unit from seed to harvest. We have actually an operational demo unit in our technology center that you see the picture on the left-hand side of the slide. There's the technology center and the growing unit under that. Well, we mainly use it for developing and testing our technology, and also for creating recipes for different crops and enhancing already made recipes. It produces so much greens that we just can't consume them by ourselves, who is working for Netlet, so we sell most of them to supermarket close by. So the distance actually from the growing unit to supermarket is only 5 miles, so that can be considered really, really local. And this way we can have a reference of the concept in general and get the feedback that matters the most. So meaning the opinion of end consumers and supermarket managers. And so far we have had nothing but excellent feedback of the quality and shelf life. At least in this part of the world, consumers are happy to buy local products. And I truly believe when consumers know where the food comes from and they know and taste that is fresh and high quality, then slightly bigger margins may be achieved. And about the demo unit, that of course we also do trials for customers. So if somebody is interested of particular variety of leafy green or herb or some other crops, we can do the trials already before they even have their own unit. And we are actually planning to expand the demo unit for a generation 3 Vera. And that means that we will have a reference of fully automated Vera system, and it also means that we will produce more greens and have more customers for them. So this also gives us a reference for even bigger business concept of vertical farming. But full disclosure, at this point, we are not aiming to be growers ourselves. So we want to be the technology provider and technical partner of the growers. But of course, we need to grow the stuff ourselves to have the reference that what our units can do. And here's about the growing cabinet that I mentioned before. So we are also putting together the first growing cabinets, which will work as a showcase in the supermarkets. We are planning to do it that way that 10-day-old seedlings will be transplanted to cabinets, so consumers will have the view to the growing method. And this is actually why we do this now, is because the supermarket managers have asked from us to make these cabinets. And we think that the best way using these are that they work as a showcase, but the actual large-scale production is outside the supermarket. It's way more economically feasible like that. And here's some of the references that we have. The biggest vertical farm where we have supplied technology has about 50,000 square feet of growing area in 2 lines and 4 layers. And those 2 lower pictures are in fact from that farm, and there's the farmer in the middle of his growing unit there. Our latest installation is probably the world's northernmost vertical farm here in Finland, and that is used mostly for plant experiments. The first cycle was done with strawberry seedlings, and what I've heard from the grower, he was really happy with the experiment, and he actually got the seedlings from the vertical farm, and he is now transplanting those to his greenhouse. So after the season, we can hear his final opinion how the experiment went, and now they are doing a lettuce experiments there by another grower, local grower there. An operator in UK has our proof of concept model, and it has a speciality for that. It uses extend heat for the microbrewery right next to the grow chamber that they have. So, and actually some of the great basil that they are growing goes in the fine beers as well. So there's a little proof of concept and example of a nice circular economy there. And just one extra application that Vera unit can do. And we are also just designing an in-store automated growing unit, which will be commissioned this year in Sweden. So like the growing cabinet mentioned before, this in-store growing unit will be installed inside the grocery store, and it will do the growing from seed to harvest. Here's the simple flowchart of the main elements of the Vera system. Well, I'm sorry about the SI units, but I hope you can get the sense of the scale at least. All the water and nutrients recycle, so Vera is extremely water efficient. Energy consumption is much lower than in greenhouses, and why we are making the comparisons with greenhouses, I think that when it comes to indoor farming, vertical farms and greenhouses, traditional greenhouses are somehow competitors. So we need to compare each other, and this is a matter that hasn't been studied so much yet. There's of course some reasons for that. Vertical farming is all the time developing itself, and so there's not just some kind of vertical farm that can be easily compared to traditional greenhouses. Of course, vertical farm versus conventional farming is very well studied, but let's not get into that at this presentation. But anyways, there's some figures that we got from the Finnish National Research Unit that made a study of the traditional greenhouses and their energy and water consumption. So the water, for example, our Vera system uses 1.5 liters per kilo, and the traditional greenhouses uses about 33 liters of water. And the energy consumption is pretty interesting, since our unit at the moment uses 8.2 kilowatt hours per kilogram of lettuce, and the traditional greenhouses uses 27 kilowatt hours. And actually, the next update that we're going to have with our LEDs is that we believe that the energy consumption will go down as much as 5.7 kilowatt hours. And also, I want to mention about the nitrate levels. I don't know if they are so big thing in the US, but in Europe and in Finland particularly, they are really well monitored. And we made a experiment with butterhead lettuce, and had a result that our butterhead had 1,100 parts per million of nitrate, and compared to average greenhouse performance rate, which is 4,000 ppm, so that's a pretty good number as well. The next I introduce our turnkey solutions. Vera Compact is suitable for urban farming, and it can work as a pathway to large-scale systems by being a proof of concept module. It only needs a building around it, and it has a footprint of about 1,000 square feet. So it has all the elements that needs to have for a successful production. So the aluminum structure with gutter logistics, lighting, irrigation, HVAC unit, software, and the growing recipes to start with. Vera Industrial is fully automated solution which has a modular design, so it can be scaled up according to production goals or building restrictions. Industrial systems come with a maintenance deal, and this way we consider us to be more like a technical partner rather than just a technology provider. And about this partnership, it can start already way sooner, and we can help putting up the business plan and securing finance. And we also have some options for the financing, like letter of credits, bank and state guarantees. And in addition to the turnkey solutions that we have, we can also design vertical and indoor farming solutions according to customers' needs. The latest custom-made design is the in-store growing unit mentioned before. We can offer solutions for high wire crops such as tomato and cucumber on its own, or part of turnkey Vera system when the high wire crop solution can benefit the same climate than the Vera vertical farm solution. For cannabis, we already have solutions and a technical roadmap to dig deeper into that industry. In fact, our Vera system is actually really applicable for cloning stage of cannabis. We have done some trials with hemp clones in our demo unit, and that showed us a really promising figures for that. And of course, we offer our LED fixtures with the 15-year experience of the LED industry. Well, I'm sure some of you are thinking that how this all can make sense from the economical point of view. And I say that's a reasonable question to make. And indeed, that is the first thing to study at the start of every project. We have our own highly sophisticated tool for that purpose, and but of course, understanding the local market is that needs to come from the operator. But how can how can we say that Vera is feasible? How can we be feasible with Vera system? Automation reduces labor and cuts operational costs significantly. Somewhat unique structure with a spacing function guarantees an excellent utility ratio per square feet. And fully controlled environment gives fast growth cycles and constant yields. And I think this is maybe the most important key for success. So like I mentioned before, Vera Turnkey Solutions comes with the software. So Vera operating system controls the vertical farm automatically. We will supply growing recipes, so commissioning can be done without extra hassle in that sense. Vera operating system enables constant monitoring and automatic and predictive diagnostics. All this can be done remotely, and Netlet's engineers are ready to consult 24/7. It can also interface with ERP systems and electricity suppliers. And for interfacing with electricity suppliers, we will have a proof of concept this summer. We can reach 0.3 degrees centigrade accuracy on temperature and 0.6% relative humidity accuracy, and we reckon those are pretty good numbers. Dusk and dawn simulations keep the plants happy and they don't stress out between day and night cycles. So this dusk and dawn simulation is, I'd say, quite sophisticated algorithm that the Vera operation system has. And just the supply process of vertical farm in a nutshell. Typical project from PO to production takes about 4 to 10 months. Specific project design is done first, followed with purchasing and manufacturing period. Installing and commissioning is supervised by Netlet engineers. And next we can see a short introduction video of Vera vertical farming system. This is the system, the demo unit that we have in Finland in our technology center. Let's hope this works. Okay, I hope you enjoyed the video. here's the list of our main references. Please visit our webpage and follow our social media channels. And of course, you are welcome to contact me personally. If you search Niko Kurumaa in LinkedIn, you won't miss me because I'm the only Niko Kurumaa in the world. So I'm easy to find. And of course, you can find my phone number and my email address from our webpage. But at this point, I want to thank organizers for having me here, and I want to thank you all for joining the webinar, and I hope you have some questions and feedback for me now. I hope not too hard questions, but something that I can help you with.
Perfect. Well, thank you, Niko, so much for presenting and for sharing all this information about your technology. We really appreciate it, and congratulations on all of your progress. I want to let the attendees of today's webinar know that they can ask a question by using the Q&A box that's found in the center middle of your screen. Or if you want to ask your question out loud, feel free to raise your hand and we will unmute you to allow you to ask your questions out loud. I have a question already from Musana. Here's kind of the context for their question. They say, I'm located in Ottawa, so need to factor in winter conditions. One of the first questions they have is the CO2 emission comparable to transportation from regular agriculture?
Well, that's a really good and important question. I think that haven't been studied, and this is something that I don't have good data, so I really can't make accurate comment on that. But if you compared, well, Ottawa and Finland have somewhat similar conditions, and so if we compared our vertical farm and traditional greenhouses, the CO2 emissions are in totally different level. So because you have to open the hatches of the traditional greenhouses. So first you put the CO2 into the greenhouse and then you let it out. And in our vertical farming solution, some of the air, maybe only 4 or 3% of the whole air coming in is blown outside. So the emissions are extremely low. So in that case, especially in North America, where food travels thousands of miles and even more thousands of kilometers, I would be brave enough to say that it is more CO2 efficient than the conventional farming in that sense. But I don't have accurate data on that.
Thank you for providing that. And Musana had another question around what are the limitations to what can be grown vertically?
Well, the Turnkey Vera system that we have, that designed for leafy greens and herbs mainly. So relatively low crops with quite fast growth cycle. You can grow berries for some extent as well in a Vera system already. Basically, of course, you can grow pretty much everything indoors and vertically if you want, but then it all comes to economically feasibility. So for example, high wire crops like tomato and cucumber, they have really slow growth cycle. So you pick tomatoes and other veggies from those high wire crops, you're using the same plant. So it's not having this constant new growth cycle. So yeah, mainly leafy greens and herbs. But like I mentioned before, you can add some high wire solutions to your whole concept and try to get into that business with those solutions.
Great, thank you. And Musana, feel free to raise your hand if you want to ask any follow-ups or place them in the Q&A chat. We have a question next from Ted, who asked, are you concentrating on human food production, and are you able to produce without chemicals such as organic?
Yeah, well, it works in a fully closed environment, so we don't use any. You don't need to use any pesticides or herbicides. and going organic or not, that pretty much up to the operator. So if operator wants to use just organic fertilizers, then it works like non-organic fertilizer. So basically, we don't make those decisions ourselves. It's the operator who makes the decision to go organic or not. Of course, it depends a little bit of the legislation. Like in Finland, you can't be considered as organic if your plant is not attached to the soil, which from our perspective feels a little bit dull. But so we can't be organic whether we are organic or not, if you understand what I mean.
Yeah, thank you. Thank you for that. We have a question from an anonymous attendee. They ask, are there any nutrient differences between the outdoor greenhouse and Netled grown crops?
What I know, we are using pretty much the basic NPK solution with some other fertilizers. Well, I'm not a crop specialist, so I'm not too well aware of the nutrients that we are using, but we are, for my knowledge, pretty much using the same nutrients that at least are used in traditional greenhouses.
Great, thank you. And jumping into another question about crops, Kurt asks, Nico, with a crop like lettuce, how long is your crop turnaround? 1 month? Do you always sell the entire plant, or can you cut and then a week or two later cut again?
Well, that's a good question. So so we go for 100 grams in 31 days with certain varieties at the moment, and for basil, for example, we go to 50 grams in 28 days. So now I can't make the comparisons to pounds and ounces without help. But anyways, so about a month is ahead of lettuce, and we are actually doing now experiments of recycling the basil substrate 3 times. So we have a customer who would like to do that. So they cut the basil, then use the same medium again, cut it, and then use it for 3rd time. So, but we are just about finishing the first rounds of that trial. So I don't have the answers yet, but yes, about a month is a growth cycle for lettuce.
Thank you. And now I'm going to jump to a question from Meg Brigman. Meg asks, could you discuss your competitors a little more?
Well, to be quite honest, we don't care too much about our competitors. We are focusing on our own solutions. Of course, we want to follow the things that are happening in the market, and the best feedback or information that I get from our competitor is from our potential customers. So basically people who are interested in our solutions, I have information from them that what other solutions they are planning to explore and how they are compared to our Vera system and other solutions that we have. So but we are making really brave claim that we are the world's most advanced vertical farm, and this is how we see it, and there's some reasons, because we emphasize automation, we emphasize high utility ratio of the building, and we emphasize the integration. So those are the 3 main things that we emphasize in our Vera system, and at the moment I think that have had a really good reception of that.
Yeah, that's great to hear. And Musana actually has a follow-up question that I think digs a little into this as well. They ask, do you consider aquaponics a viable alternative to traditional agriculture and vertical farmer? Would appreciate any comparison comments that you can make.
Yeah, of course. I think there's a place for hydroponics. There's a place for aquaponics. There is a place for aeroponic. But the hydroponic nutrient film technique is the solution, the method that we think that is the easiest to make automation out of it. So aquaponics, aeroponic, they are really sophisticated growing methods, but maybe from our point of view, they are not so well automated and integrated, and maybe not so well making economically feasible. But that's of course our opinion, and I'm not an expert of those other growing methods, so might not be the best person to make the comparison, but that's some comments that I can make on that.
Great, and thank you for providing that perspective. Kurt has a follow-up question. Kurt asks, kind of in relation to when we were talking about lettuce. He asks, do you sell the entire plant? Typically, if I'm in your grocery store, I will buy the entire fresh plant of lettuce, roots, container, and all. Or do you just cut and sell the leaf as part of what people use these systems for?
Yeah, well, in Finland, for some reason that I don't know, the leafy greens and herbs are mostly sold with the pot, so with the medium, with the roots, which is actually really good thing. So you can actually just continue irrigating the greens when you are home. So then your basil can last pretty long time, at least if it's grown in a Vera system. So that has a really good shelf life even back home. So if I take a basil with the growing medium back home from our unit, it can last for a couple of weeks if I just keep irrigating it. But of course, then it's according to market. So I understand that in North America, the stuff is usually sold cut. So then comes to our processing unit has the best application then. So then it can do the transplanting and the harvesting, and then you can actually add a packing machine. So you can add post-harvest automation that of course we can provide. So then you can have the harvesting and packing automatically. So it's just about the market, how you want to sell it. Then we design the system like that.
Great, and thanks for sharing that perspective. I know I certainly would like my basil to last longer and come with its roots, and that sounds wonderful. I guess one kind of next question would be, what are some of the greatest challenges facing growers that are looking to move into vertical farming systems or looking to adopt your system?
Well, one thing the first comes to my mind is securing the finance. So that has been a big challenge. I'd say that we would have had quite a many more bigger systems globally already if the operators have a better chance securing the finance. So that is really a challenge, and because it's such a new industry. One Canadian gentleman from Montreal told me about half year ago that he went to the bank to ask loan for the vertical farm operation, and they asked that what kind of farm, where's your tractors? So those conventional institutions don't necessarily understand the vertical farming and its capabilities. So that is really a challenge, and that's why I mentioned in the presentation that that's something that we want to help as well. So we understand that the banks and private equity market, venture capital, wherever the money comes from, they are concerned about the technology. So if somebody is interested of our technology, we want to sell the technology also for their financiers. And of course, the that one side of the challenges. And then other side is that although it's a highly sophisticated technology, it can be cost efficient. It gives a high quality, good product, but still somebody has to sell the product. So, and that's something that the operator needs to do. We can teach the growing part. You don't need to have any agricultural experience whatsoever. We carry the technical risk with the maintenance deal, so you don't need to worry about the technology, but the things that you need to worry about is the actual business plan, securing the finance and selling the product. So the first things that if somebody is thinking about vertical farming, putting up an operation, I would start thinking about how I can finance it, and I would pick up the phone and start calling to wholesalers, retailers, wherever you are planning to sell the product. So those are the biggest challenges, I'd say.
Yeah, really interesting. Thank you for providing that perspective. Attendees, I want to let you know, please feel free to add any additional questions that you have in the Q&A module. But Nico, I'm going to be sure to ask you a question I like to ask everyone. What can the audience help you out with here, and how can they best find you?
Well, I think the best way is to follow our social media. We try to be really active on there. We share the developments that we have done. We do monthly newsletters. We share our views of the industry, of vertical farming and agriculture in general. So I hope everybody who is listening follows the Facebook and LinkedIn of Netlet if you are using those medias, and yeah, be active. If you have any questions whatsoever, don't hesitate to drop me a message, email or LinkedIn, wherever. I will answer to your questions. I can assure that.
Great, thank you so much, Nico. And I do actually have one more question from Kurt, and he's kind of asking around economics for what plants you grow. He's curious if, of course, you have herbs and tomatoes. What plants do you think work best economically in this type of system?
Well, that's a hard question. Of course, it depends on the market again, but I think if you can move the lettuce grown in vertical farm, that's of course a good solution, because then you can have big quantities with fast growth cycles. The lettuce, of course, if you are competing with extremely low prices, lettuce coming from Mexico or California, and you know that there's no customer based on your indoor grown lettuce, which can be a little bit more expensive. But like in Finland, we know that we can actually grow lettuce more cost efficiently now than the traditional greenhouses. So we can compete with the main products here, because most of the greens are produced in Finland. But of course, other countries have different markets. And then some of the most successful crops that we have grown in the Vera system are different varieties of basil, coriander, thyme, parsley, sage. So there's many different herbs that you can choose. Of course, if you have a large system that produces like 3 or 4 million heads annually, then it might be hard to sell the 4 million heads of basil. Then you need to make a plan. So maybe I grow 1 million heads of lettuce and 1 million heads of basil, then some parsley, some thyme. So it's about knowing the market. But what I understand, for example, in Canada, you can be successful with just basic lettuce, but you can be extremely successful with, for example, basil.
That's really interesting. And Kurt also kind of asked a question around, would potatoes be something that would be reasonable to grow in these kinds of systems, or would they have too long of growth cycles?
Yeah, they have too long growth cycle, and maybe the light intensity needs are a little bit overwhelmed for vertical farms. So I don't know the specifics, but these kind of crops are not viable in vertical farms, at least at the moment. Maybe in some decades it will be, but not at the moment. Now we have to do the greens first, that we are already doing, and now we are moving up to high wire crops and making those more viable. So this is how we do it at the moment.
Perfect. Well, Nico, I want to thank you for sharing all of the information about Netled today and for taking the time to talk to us. We really appreciate your discussion around this. And I also want to thank the attendees for their engaging questions. And I want everyone to know that we host these calls every week at 3 p.m. Central, and you can register for the Agrifood Conversations webinar series by going to agrifoodconversations.com. All of you will be receiving a replay of this webinar in the next 24 hours. And if you know someone else that you think may want to see this webinar on replay, feel free to forward them that link or send them to our website at agrifoodconversations.com. Nico, thank you so much.
Thank you very much. Thanks, Hannah.